This video is going to provide a brief tour of the SWM interface. The SWM models, similar to EPANet, are constructed of links and nodes. The links can have properties like conduits, they can be open channels, or they can even be a pump system. The nodes are ordinary nodes that join links. They're also locations where the outlet from a subcatchment, or think of a small watershed, can drain to a node. And they have some other properties. There's flow dividers, there's orifice outlets, and so forth up here in the menu where you select whether you're going to have French fries or onion rings. There's one special type of node, which is the upside down triangle. It's an outfall node, and all SWM models have to have one outfall node for them to run. The outfall node plays the same mathematical role that a fixed grade node or a reservoir played in EPANet. Nodes can also be storage elements. So there's this storage element up here where the cursor is cursing right now. And nodes can be converted between storage elements and ordinary nodes. Let's go ahead and put a node, an outfall, a conduit to join them. So that takes care of nodes and links over here. We've also addressed the outfall. The outfall properties are shown here in a dialog box, and the properties that are going to be important later on are whether it's a free outfall, normal, fixed, or tidal, or time series. And I want to return it to free. If you're using the Macintosh version, the pull-down menu doesn't work. I'm using the up and down arrow to select the type. And you have to be kind of ornery sometimes. There we go. I used the left arrow until I could get it onto the word I wanted, and then I switched to a different part of the dialog box. So right now it's a free outfall, and this other information down here becomes irrelevant. What a free outfall means is that the computer program will compute the critical depth at that location and force the flow at any time step to be at critical depth at the outfall. Here's our node. A node has information such as its name, and an important element is the invert elevation and the maximum depth of the node. And there'll be a slide shortly that'll explain what those are in pictures. The link right here is defaulting as a circular conduit, 1 foot in diameter, 400 feet long, Manning's N of 0.01. The links can be offset relative to their connecting nodes, and there's a picture to show what that means coming up subsequently. The next concept is the subcatchment. The subcatchment is this box here. It's contained in the hydrology section of the project defining, and I'm left clicking to draw a subcatchment, and to close the drawing I choose the right click. Now the subcatchment currently isn't connected to anything, but in the subcatchment data sheet, if we set the outlet to junction 1 and close it, it'll draw a dashed line indicating that whatever comes out of this subcatchment goes into node 1 or junction 1, and then whatever hydraulics happens after that is up to the junction. To provide rainfall, I've selected the rain gauge, looks like a cloud. And in the rain gauge data, we can enter time series and intensity, and this is saying at 1 hour intervals. And if we double click here, we can call up my time series. And we can either use calendar, day, and clock time, or you can do it as a lapse time. If we don't put dates, it's an elapsed time. So these are at hour 0, 1, 2, 3, 4. and perhaps at hour 0 there's no rain, hour 1, 1 inch an hour, hour 2, 1 inch an hour, hour 3, 2 inches an hour, back to 0. And we can view it, and we can use the graphic to check that we put in the data the way we thought. Otherwise, other than that use, this particular graphic's pretty useless. Choose OK. We go back to the subcatchment, and we tell it it's rain gauge 1. And now the rain gauge is connected. We'll go ahead and change the invert elevation to 1, so that with this pipe being 400 feet long, it drops 1 foot in 400, which is a 0.25% slope. And the next we have to subscribe is the date and time. That's up here in the options. By default, I've set mine up to always do a 6-hour run. But the start analysis, start reporting, and end analysis, the days can be the same, but the start time and the end time have to be different. Otherwise, the program will run but produce no output because no time occurred. The time steps, I'll currently just take the defaults, and right now I have it set up as, I'll set it up as a steady flow. Now, kinematic wave model. And the kinematic wave is exactly what you had in hydrology. Run the program, and if we want to look at the output, it shows the flow in the link. Okay, the hydraulics will evolve as you build a more and more complex model. You'll have hydraulics of pipes, you'll have hydraulics of channels, and you'll have these connections to the subcatchment. And then the hydrology is contained either entirely in the subcatchment or in the infiltration portion, which is done up in options. So in options, you have different infiltration models: Horton, modified Horton, green amped, and curve number. Okay, that concludes the tour of the interface.